In this video, I'm going to show you how to do a combined non-pairwise type of contrast, which is the third least popular, I would say, approach to conducting contrast analyses, where you want to combine the means from two or more groups and compare that combination of means with one or more combined means in the other portion of the comparison. And so the example that I have here is drug A, drug B, and control. And in the textbook, I write that the researcher conducts the analysis and might not find a difference between any of the means. In fact, let's just check it out with a regular ANOVA, where we see if there are any differences between the three group means. And we find that it is not statistically significant. We have no evidence to reject the null hypothesis that drug A and drug B and control group have different means. They're numerically different, yes, but statistically they weren't found to be different from each other. They have all equal sample sizes. A researcher, though, might actually take a look at the graph, even though that might be inappropriate in the context of a planned comparison. You shouldn't really be snooping in your data. But a researcher might hypothesize that drug A and drug B combined, in terms of a combined treatment group mean versus a control group mean, might yield a statistically significant effect. Now, this doesn't mean that if people take drug A and drug B, what would that effect be? It's really not about taking two drugs at the same time. It's really just about combining two means together and comparing those two means against the control group mean. And this is what I describe as a non-pairwise comparison. There could be different words for it. Arguably, the linear and the quadratic contrasts are not really pairwise comparisons themselves, really, usually. But I use that term for this type of comparison where you're combining two means or more and you're comparing it against one or more other means. So to conduct the analysis I did in the textbook, you can go into Analyze, Compare Means One-Way ANOVA, and you've got the dependent variable in the dependent list and the independent variable in the factor list, and click on Contrast. And in this case here, I need to specify coefficients that reflect the hypothesis that the treatment groups are going to have a lower cholesterol level mean, because we would hypothesize that the drug actually works at reducing cholesterol levels. And one set of coefficients that reflects that is negative 0.5, negative 0.5, and then plus 1 for the control group. So that is reflective of lower means for the two drug groups and then a higher mean for the control group. And because these weightings are 0.5 for each of the drug groups, they're basically getting half a weighting each, and they're being combined together. So this non-pairwise comparison is saying if you combine drug A and drug B means and compare those combined means against the control group mean, do you get a statistically significant result? And the answer is yes, you do. Here's ANOVA producing this regular ANOVA table. We don't need to pay attention to that. Here are the contrast coefficients, negative 0.5, negative 0.5, and plus 1. For this comparison, so it's combining drug A and drug B into one mean, and it's comparing it against the control group. And we find that if you assume equal variances, which we can because we haven't violated that assumption with the Levine's test, we get a t of 2.269 with 27 degrees of freedom, and it's less than 0.05. Because it's less than 0.05, we can reject the null hypothesis of equal combined means versus the control group. So if you are a researcher, this would be the most powerful approach to going about your analysis, to see if there is a treatment effect for either drug against the control group, and you find that there is a statistically significant effect. If you only did the analysis based on the ANOVA, the regular ANOVA, you wouldn't really find anything. Alternatively, you could do a Kramers HST comparison, but I suspect that will also, even though it's a single-step procedure, I suspect you won't find any differences there either. In fact, let's just try it out for fun. Compare means one-way ANOVA, post hoc, and let's go with Tukey. And we have the multiple comparisons here, and in fact, none of them are statistically significant. So a lot of people would be stuck at doing an ANOVA, not finding significance, doing Tukey's HST, not finding significance, and they would be stuck there. But if you did a contrast analysis that was theoretically defensible, then you would actually have something potentially to talk about, because it was actually statistically significant.